Welcome to my today class. In this class, I'm going to discuss some more problem based on Fourier series. One problem is already on the board. The problem is find the Fourier series of f of x equals x into cos x in the interval minus pi to plus pi. Instead of x cos x, they're going to give function like f of x in the same interval. It may be x sin x. You try afterwards x sin x, and also in my course material already I solved x sin x also. Okay. Now I'm going to explain how to solve the function f of x equal to x cos x in the interval minus pi to plus pi. The very first step I told number of problems we already discussed in the previous my videos. Given f of x equals x cos x over what's the interval minus pi comma plus pi. Now I told number of times before going to start, first you observe the given interval. What is my given interval is minus pi to pi. Is referred to the first case or second case was what I discussed in my second class. Based on my second class, the given interval is in the form of second case. What's the second case? Minus L to plus L. Whenever function is defined in the interval in the form of minus L to L, now before going to construct the Fourier series, we have another step is to verify even or odd. How to verify even or odd here? Here, now I'm going to take here f of minus x. Instead of x, I'm going to replace minus x. What we get? Minus x into cos of minus x. You already know that cos of minus theta is cos theta, therefore minus x into cos x. Now once you replace x by minus x, we get the same function but you have a negative sign. Therefore minus of f of x. Now once you replace x by minus x, we get same function minus of f of x. Therefore the given function is an odd function. Therefore now the given function is an odd function. Odd function in the corresponding interval. Odd function in the given interval. Whenever the function is odd function, what are the values of 0? A0 and En are 0. And A0 equal to 0 and En is equal to 0. Now, before going to construct the corresponding Fourier series, first I have to know what are the values of L. Now, in the second case, what's a general interval minus L to L? The given interval is minus pi to pi. That implies L is equal to pi. L is equal to pi. That implies n pi x by L is nothing but nx. Once you substitute the value of L, pi cancel. The corresponding Fourier series f dot s means for my convenient I written a Fourier series for f of x over what's the interval minus pi to plus pi is f of x equals summation in ranging from 1 to infinity bn sin nx, where what's the formula for bn? Bn is equal to 2 by L. What is 2 by L? Is 2 by pi, 0 to pi, f of x sin nx with respect to x. Now using this formula, I have to find out the value of bn. Now see, now 0 to pi, now this is a very simple, now 2 by pi, 0 to pi, what's the function you have? X cos x into sin nx with respect to x. This is a function, you already know this is a product of two functions. See, observe carefully, can't go for here UV rule or Bernoulli's rule because it's a product of two functions you have. See, observe now cos x into sin nx. They have a product of two functions and also x. Using transformation formula, first I have to convert into this product of two trigonometric functions must be equal to sum or difference of trigonometric functions. Therefore, you know that this is just like 2 cos A sin B. What is 2 cos A sin B? Already known that sin of A plus B minus sin of A minus B. Minus sin of A minus B. Now I have to know what are the values of A and B. A is equal to x and B is equal to nx. Now what we get, A plus B is nothing but, now x plus nx, what's a common factor? X is common factor, 1 plus n into x. What is A minus B? 1 minus n into x. Therefore, now what we get from this formula, from cos x into sin nx, you know that. Now I'm going to write it directly for here because you know how to simplify. You have to take it to us inside the bracket. We get 1 by pi, 0 to pi, x into sine of a plus b. What is sine of a plus b? Sine of 1 plus n into x minus sine of a minus b, 1 minus n into x with respect to x. Now this is a thing I think is clear. I written already what is a, what is b, what is a plus b, what is a minus b. Now before moving to the next step, first you have to multiply with what actually x. What we get actually x into sine of 1 plus n into x with respect to x minus 0 to pi x into sine of 1 minus n into with the x with respect to x. Now both the term is a product of two functions. I go for UV rule or Bernoulli's rule. Now while taking UV rule or Bernoulli's rule, which one is a u function, which one is a v function? X is my u function because after the first derivative x is 0. Therefore x is my u function, then sine function is v function. Like that, here x is u function, v is nothing but sine function, because you know that once you apply the first derivative, what happens? Derivative of x is constant. Now then what about the first, the remaining higher terms must be 0. From UV rule, this is nothing but x into integration of sine. What is integration of sine? Minus cos of 1 plus n into x divided by, divided by quotient of x. What's quotient of x here? 1 plus n. 1 plus n. And then minus differentiation of x is 1. Again I have to integrate cos. While doing integration, keep minus 1 by 1 plus n as itself. What is integration of cos is? Sine of 1 plus n into x divided by 1 plus n into 1 plus n, what we get? 1 plus n whole square. Now once you get derivative values constant, that is my last term of UV rule, because further higher derivative of value of the constant must be 0. Now 0 to pi. And then minus, again I go for UV rule. Now while taking UV rule, x into, what is integration of sine? Minus cos of 1 minus n into x divided by the quotient of x is 1 minus n, and then minus differentiation of x is 1. Again while doing integration, keep minus 1 by 1 minus n is constant, sine of 1 minus n into x divided by, it's divided by again the quotient of x. What we get actually, again the quotient of x is nothing but actually 1 minus n. You already have 1 minus 1. What we get actually, 1 minus n into 1 minus n is 1 minus n whole square divided by 1 minus n whole square. Now what is my limit? 0 to pi. Close the square bracket. Now while applying the upper and lower limit, we have to take care for this 1 by pi. I told number of times while applying upper and lower limit, keep minus of 1 by 1 plus n is a constant. Apply the upper limit. I told number of times whenever I am going to apply upper and lower limit, first you have to verify what happened, the corresponding limit for product of any one cos or sine. Some of the case what happens, sine value may be 0, cos may be 0 based on the corresponding limit. That's why I told whenever having a product of sine or cos, first you have to verify what happened, that value. Now I'm going to write it this value here in the here. Before I'm going to move the next step, first I have to verify what happened, what about upper and lower limit based on cos and sine. And I'm going to explain, even though it's a simple thing, please try to understand that how we get. Now cos of 1 plus n into, what's the upper limit is pi. Yeah. Now this can also be written as cos of pi plus n pi. You know that what is cos of pi plus theta. What is cos of pi plus theta is minus cos theta. What is theta here? Cos of n pi. You already know that what's the value of cos n pi is minus 1 to the power of n. And next you know that what is cos 0. Cos 0 is 1, not necessary to explain. Next you have to verify. Here having cos of 1 minus n into upper limit is pi. Now what we get actually cos of pi minus theta. What is cos of pi minus theta is minus cos theta. Minus cos of n pi. What we get here also minus of minus 1 to the power of n. Next try to verify based on sign. Sine of 1 plus n into pi is nothing but sine of pi plus theta. Sine of pi plus theta is minus sine theta. What is my sine theta is n pi. What is sine of n pi is 0. Similarly, sine of 1 minus n into pi. First you multiplied by pi, what we get sine of pi minus n pi. What is sine of pi minus theta is sine theta. What is my theta is sine n pi. What is my sine n pi value is 0. Now that's why I told before going to apply the limit, first I have to simplify that. Whenever having product of sine or cos, first you verify what happened the corresponding limit, the cos and sine value. Now based on that we are going to write what are the values of what actually first term and second term, etc. Now move to the next step. Now while applying the limit, first try to keep the constant. What's a constant here? Minus 1 by n, 1 plus n is a constant. Now you already know that once you apply the pi value, cos of 1 plus n, cos of 1 plus n is nothing but actually you already know that minus of minus 1 to the power of n. Therefore, that is not equal to 0. Apply x is pi. What we get? Minus of minus 1 to the power of n. Minus x is 0 but cos 0 is 1. Now, you already know that this value is 0. So, sine of 1 plus n into pi is 0. Sine 0 is 0. Therefore, entire thing is 0. Similarly, sine of 1 minus n into pi value is 0. Sine 0 is 0. Therefore, not necessary to apply the limit for these two terms. The next is, now this is not necessary to do it. Now, minus into minus, what we get actually plus 1 by 1 minus n. 1 minus n, apply the upper limit. What's upper limit? Pi into cos of 1 minus n into pi is nothing but minus of minus 1 to the power of n. Minus x is 0. 0 into cos 0 is 1. Simplify that. From these two terms, what's a common factor? Only you have two terms. What are the two terms you have now? These two are the two terms. This and these two are the two terms we have. Now carefully I have to simplify. What's a common factor from these terms? Minus pi into minus 1 to the power of n by pi. Pi already is there. What's the remaining? 1 by 1 plus n plus 1 by 1 minus n. Okay. Now pi is cancelled. Okay. Now I to take LCM. What happened now? 1 minus n plus 1 plus n divided by 1 minus n into 1 plus n. N cancel. I think is clear. N cancel. 2 we get. Now what we get actually minus 2 divided by a plus b into a minus b is nothing but what actually 1 minus n square. That can also be 2. Actually, what are the terms are cancelled here? Maybe I did mistake here. Yeah, minus into now here. See, observe carefully here. Yeah, I did mistake here. Observe carefully. What mistake I did know? Here, minus, correct. This is actually minus into minus plus. Yeah, once you take plus now, what are the terms are cancelled? The terms are cancelled are nothing but here. Now observe carefully. Now see, maybe I did somewhere mistake here. Try to understand that. This is a thing. Observe carefully here. minus pi into minus 1 to the power of n is fine. Okay, correct. This is nothing but actually this is actually minus into minus what we have plus, yeah, yeah, plus upper limit minus the lower limit. Now, yeah, plus minus into minus plus, then we get this. Yeah, yeah, yeah. Now see, observe here. What I did mistake here, I'll tell you one thing. Here we taken my, now see, observe here, upper limit. Yeah, we again have minus sign. Yeah, here I did mistake. What's a mistake I did now here? Observe carefully. Here already I keep minus sign. Minus into minus plus. Plus into minus is minus. Not necessary to take minus sign outside. Please observe carefully. This is I did mistake here. Therefore these two are not cancelled. Which one is cancelled? Observe carefully. This is a thing we have to take care for this. And also observe this is actually you don't have minus sign outside. Please take care for this. This is one of the important thing I have to take care. Now observe carefully here. Now, yeah, minus into minus plus, okay, fine. Now, and also plus into minus is minus. We are not going to take minus sign outside. Only we are going to take what? Pi into minus 1 to the power of n is outside. What's the remaining? Pi. Yeah, observe carefully. Minus into minus plus. Here, minus. Once you take suppose you have to take minus sign outside, this become minus, this become plus. Okay. Now what's the LCM? 1 plus n into 1 minus n. What we get? 1 plus n. 1 minus n, because this comes in numerator. Okay, fine. Yeah, 1 minus n. Minus of this minus 1 minus n. What's the remaining here? The remaining is actually what are the terms are cancelled here? Plus 1 and minus 1 cancel, we get minus 2n by n square. That can also be written as 2n divided by n square minus 1. I think everyone is clear where I did mistake here. Minus into minus is plus, plus into minus is minus. We have taken only pi into minus 1 to the power of n as common factor. Therefore, what are the things are cancelled? Pi are cancelled. Now this is as itself. Now what are the terms are cancelled? Plus 1 and minus 1 are cancelled. I think it's clear. Now when to take minus n inside, we get this is nothing but 2n divided by n square minus 1. I told number of times before moving to the next step, I have to take care whether this n is true for all values of n. How can you know that n is what actually? 2n divided by n square minus 1. Now, before moving to the next step, first I have to know whether it's true for in this summation is ranging from 1 to infinity. How can you know that? Pick the denominator. What is my denominator? N quantity n square minus 1 equal to 0. Simplify that n is equal to plus or minus 1. But anyway, your summation start from 1 to infinity. We are neglect negative value. Only I have to observe positive value. Yeah, n is equal to 1. What happened? This is n is denominator 0. Numerator not equal to 0, denominator 0, what happened? That becomes infinity for n is equal to 1. Now, this an is true, is not true for n is equal to 1. Suppose here for an we get n is equal to 1, we get infinity. We can't say that a1 is infinity. Such type of value I have to find out separately or independently. Please keep in mind for what value of n, an or bn is equal to 0. Take that value separately, find out from the corresponding formula. For example, here I have to find out n is equal to 1 from the formula for an. Definitely in that case you don't get it, a1 value is infinity. Definitely we get finite value. Keep in mind, once we get an value, pick the denominator equal to 0, observe. Here we get plus or minus 1, but our summation start from 1 to infinity. Now 1 is included. For n is equal to 1, what happens? This is an is infinity. What we get a1 is infinity, can't consider that a1 value is infinity. Such type of value I have to find out independently, individually from the corresponding formula. This thing is happen only the case the function having trigonometry function. Sin or cos we have, there we are applying transformation formula. Once you applying transformation formula, there we get in one denominator n square minus 1, n square minus 4. Now corresponding the value of n is not defined. Please take care whenever the given function having a trigonometry functions, after that you are applying transformation formula. Once you apply the transformation formula, definitely we get denominators of the form n plus 1 or n minus 1, n plus 2, n minus 2. In such cases, some particular value of n for 1 to infinity, n or bn is not valid. It's not valid means we get infinity. And to find out the corresponding the n value independently or individually from the corresponding formula. Now here which value is not true is this is not true. Otherwise you write n is greater than 1 or you have to write n is equal to 2, 3, etc. Now n is equal to 1 is infinity. You can't accept that. I told I to find out n is equal to 1 independently. How to find out? This is my whatever. This is not en actually. This is my bn. This is my bn. Okay. How to find out that b1 value? How to find out b1 value? This is my bn, not en. Now how to find out bn? Now we have to take this formula, what you already done, bn formula, take it as star. Take it as star. Put n is equal to 1 on both sides. Here I have to put n is 1. Here also put n is equal to 1. What happened? X cos x sin x we get. I am going to write that formula way for bn. I have to find out b1 value independently or individually. Why I have to find out here? Bn is not true for n is equal to 1, 2, 3. That's why I taken this formula. Keep in mind whenever you are applying transformation formula, in before going to evaluate integration, you must and should have to take care whether a and bn is true for n is equal to 1 to infinity. Now I am going to put n is equal to 1. In how to find out? Suppose any value of n or a and bn is infinity, you find out corresponding value of n independently from the corresponding formula. Put n is equal to 1 in star, we get what star is bn formula. b1 is equal to 2 by pi 0 to pi x sin x into cos x. You already know that 2 sin x cos x is nothing but sin 2x. 0 to pi x sin 2x with respect to x. Again you go for UV rule. From the UV rule, x into what is integration of sin minus cos 2x divided by 2 minus what is differentiation of x is 1. Again integrate what is integration of cos is sin of 2x divided by 2 into 2 is 4. Not necessary to move further step because the derivative value is constant here. Stop this, apply the upper and lower limit. While applying the upper and lower limit, what we get actually minus half apply the upper limit. What's upper limit is pi. Cos 2 pi. What cos 2 pi is 1. Minus x is 0. 0 into cos 0 is 1. Yes, next is minus into minus plus. Yeah, this sine function what happens? Sin 2 pi and sin 0 is 0. Put x is equal to pi, sin 2 pi is 0, sin 0 is also 0. Okay. In the next step, pi cancel, we get minus half. Minus half is not a constant value. Here we get n is equal to 1 infinity, but here we get p1 is minus half. That's why whenever, how can you know that for what value of n is not true? Once you get bn or en, pick the denominator quantity equal to 0, simplify that, we get two values. I am neglecting negative because summation start from 1 to infinity. But in this one we get infinity. You can't treat it p1 is infinity. I have to find out that value from the corresponding formula. Just put which value we get, n value we get infinity, put that value of n in the formula. We get corresponding formula. Simplify, integrate carefully, apply the upper and lower limit. Definitely we get some finite value. Okay. Now I am going to construct the Fourier series. While construction of Fourier series also, don't take entire the summation here. Now here our what about our Bn is not valued for n is equal to 1. Therefore, what we are going to do here, actually, first I have to take first term of the summation b1 sin x and then the Bn is true for n is equal to 2 to infinity. Bn sin nx. Now I have to substitute the value. What is B1 minus of into sin x. While writing Bn, what is a constant 2n ranging from 2 to infinity? N divided by n square minus 1 sin nx is the required Fourier series of the given function over what's the interval minus pi to pi. I think everyone is clear how you have to construct the Fourier series. That's why I'm discussing this problem. These things are happen whenever in the given function having a trigonometric function. Whenever having a trigonometric function, while evaluating Bn or En, we are going to use transformation formula. You must and should have to take care while once you use the transformation formula, definitely any one of the value of En or Bn is not equal to you don't get it finite value, we get a infinite value. Yeah, this is one of simple example, x cos x. This function is in the form of second case. What I did first, I had to verify even or odd is an odd function. Therefore, what are the values of 0? A naught and n is 0. And then I have to construct the Fourier series based on the odd case. Once you construct that, try to find out Bn. While finding Bn, we are using transformation formula. Once you use the transformation formula, you have to take care while finding An and Bn value. I return that is also. After once you apply the transformation formula, once you evaluate, definitely we get denominator is in the form of a square minus b square. Now, how can you know that which for what value of Bn or En is not equal to? We cannot, it's not a finite value, maybe you get a infinite value. You pick the denominator equal to 0, solve that, you find out the value of n. Whether after that verify whether that value included or not in the summation. Yes, here is included for n is equal to 1. Therefore, this Bn is not true for n is equal to 1. How can you proceed? I have to find out corresponding value of n by using formula for Bn. Just put n is equal to 1 in the formula of Bn. We get, this is my actually B1 formula. Once we get B1 formula, evaluate, we get a finite value. And then while writing a construction of Fourier series, you take the first term of the summation separate. And then you have to write it, the remaining 2 to infinity. This is a way to construct the Fourier series. Before I move to the next problem, keep in mind whenever having a function is nothing but is a what type of function is function is having a trigonometric function. Suppose they use transformation formula, there we have to must and should have to take care to once you write the formula have to write an and bn final formula. Definitely is not true for all n ranging from 1 to infinity whenever we have to use transformation formula. Okay, now I move to the next problem. I think everyone is clear how we get this. Yeah, if we want to zoom out entire thing, but it's very small thing. Now here, yeah, if we, yeah, observe carefully. This much is possible at showing that entire problem in one shot, one screenshot. Okay. Now I move to the next problem. Okay. Next problem. Find the Fourier series today's second problem. Find the Fourier series for the function say if f of x equals -2 is less than x less than 0, x for 0 less than x less than, and hence deduce that pi by 8, pi square by 8, pi square by 8 equals summation n ranging from 1 to infinity 1 by 2n minus 1 whole square. Yeah, find the Fourier series for the function f of x is equal to what actually? Minus 2 for minus 2 to 0 for x range from 0 to 2. Hence deduce that pi square by 8 is equal to summation in ranging from 1 to infinity 1 by 2n minus 1 whole square. Now deduce part is final step. First I have to observe the given function. What is given actually? Given f of x equals minus 2 is less than x less than 0 for x lies between 0 to 2. Now I told in my previous video, whenever having a given function, splitting function, first you take overall interval. What is our overall interval? Is minus 2 to plus 2. Overall interval is minus 2 to plus 2. This shows that this is given interval is in the form of minus L to L. Whenever the given interval is in the form of minus L to L, now we are possible to step into another step is what? Even or odd definition. Now I have to verify whether it's an even or odd. How to verify now? Just replace x by minus x. What we get actually? Once you replace x by minus x, minus 2 is less than minus x less than 0, minus x 0 less than minus x 2. Just replace instead of x by minus x. Now it's already explained my previous video this inequality. It can't verify minus f of minus x is equal to f of x. Here based on the x I have a limit here based on minus x. What we are going to do here? First I have to simplify this inequality using basic concept. You know what is basic concept of this? Now here, what is my basic concept of this actually? Once you multiplied by minus x, what we get actually? This can also be written as 2 greater than x greater than 0. Means 0 less than x less than, okay. Now where to this inequality, once you multiplied by minus sign, what happened? Minus 2 is less than x less than 0. Okay, just you multiply this inequality by minus n, what we get? X greater than x 0 greater than x greater than minus 2. Now minus 2 less than x less than 0. That's all. Now observe here minus 2 to 0. What's a function? Minus x. Minus 2 to 0. What's a function in given? Minus 2. Therefore this is not equal to f of x. And next, if possible, I have to verify is an even or is not a even function. Odd. You take minus and common outside. What we get? 2 less than x less than 2 x minus 2 less than x less than 0. Observe minus 2 to 0. Here x, here minus 2. Therefore, this is not equal to minus of f of x. Observe carefully. Minus 2 to 0 is minus 2. Here, minus 2 to 0 is minus entirely different function. Even though I have to take minus sign, you don't get it to minus 2. Therefore, not equal to minus. Suppose it's not satisfied one of the limit, not necessary to verify second limit. Because in the given function, minus 2 to 0 is minus 2, but here minus x is not equal to f of x, is not equal to minus of f of x. Therefore, the given function is neither even nor odd. This is one of the example, even though interval is in the form of minus 2 to 2, but the given function is neither even or not. Therefore, the given function is neither even nor odd function over what's the interval minus 2 comma plus 2. Okay, now it's not neither even or odd. Now we are how to construct the Fourier series. I have to construct the Fourier using second case of the formula, and the corresponding Fourier series for f of x over what's the interval minus 2 to 2. Yes, yeah, interval is minus 2 to 2. What is my second case limit is minus L to L. What we get here, L is equal to 2. L is equal to 2, therefore n pi x by L is nothing but n pi x by 2. Yes, I told number of times before you construct the Fourier series, first you have to know what's the value of L based on the general case of the interval. Now what's my Fourier series expansion? F of x is equal to a naught by 2 plus summation in ranging from 1 to infinity a n cos of n pi x by L. What is L here? 2. Plus summation in ranging from 1 to infinity b n sin of n pi x by 2. Okay. Wait, what is my A naught formula? As usual, 1 by L. Don't write 2 by L, 1 by L. What is L here? 2. 1 by 2. What is minus L to L? Minus 2 to plus 2 f of x dx. What is my n formula? 1 by L, 1 by 2, minus 2 to plus 2 f of x. Yeah, instead of n, what we are going to take f of x cos of n pi x by 2 with respect to x. What is my bn formula? 1 by 2 minus 2 to 2 f of x sin of n pi x by 2 with respect to x. Now, as usual, next try to find out my f of x and a naught, en and bn using f of x. Okay. Now, what is a naught? Now, you can't find out a naught directly because you know what is my function. What's the function they given here? F of x is minus 2 or minus 2 to 0. X 0 to 2. This is my function. Okay. Now, first I have to split the integral. How to split? I have to give a bracket 0 minus 2 to 0. What's a function? Minus 2. Yeah, based on what they are given, I'm going to take it directly because you solved some few problems based on splitting function. 0 to 2, what's a function? X into dx. Okay. Now 1 by 2. I'll keep the constant minus 2 outside. Integration of 1 with respect to x. What we get? X minus 2 to 0. Plus, what is integration of x is x square by 2. What's the limit? 0 to 2. Now, yeah, this is nothing but 1 by 2 of, yeah, I'll keep minus 2 outside, apply the upper limit 0, minus lower limit minus of x is minus 2. Most of the students, they are doing mistake. Minus 2 outside, upper limit minus of the x is lower limit is minus 2. Okay. Plus 1 by 4, upper limit 2 square 4 minus lower limit is 0. You simplify that half of, now what we get? Minus into minus plus, plus into minus is minus. What we get actually? Minus 4. Okay. This is actually, observe carefully, this is, no, I did mistake, 1 by 4, not 1 by 4, this is 1 by 2. Because I'll keep the constant outside. What's the constant? 1 by 2. Yeah, x square is 4. Yeah, 4 by 2. What is 4 by 2 is 2. What we get actually? Minus 4 plus 2 is minus 2 by 2. What we get? Minus 1. This is my A naught. This is my A naught. Okay. Once we get A naught, next I have to find out what is my AN and BN very carefully. This is a very, very important. Yeah. Next, I have to find out what actually AN. 1 by 2. Yeah. Now we have to split the integral. Minus 2 to 0. What's the function? Minus 2 into cos of n pi x by 2 with respect to x. And then 0 to 2. What's the function? X. Cos of n pi x by 2 with respect to x. The first term you know how to integrate, but second term you go for UV rule. Yeah. Which one is u function? As usual, x is u function. This is v function because after the first derivative, x is 0. Now from the integration, minus 2 is a constant. What is integration of cos sine of n pi x by 2 divided by what is the quotient of x is n pi by 2. Yeah. What's the limit here? Limit is minus 2 to 0. Yeah, while come to this step, I go for UV rule, x into integration of first UV function, second function. Or integration of cos is sine of n pi by pi x by 2 divided by the quotient of x is what n pi by 2. Minus what is differentiation of x is 1. Again integrate, what is integration of sine is minus cos of n pi by pi x by 2 divided by the quotient of x is n pi by 2. We get n pi by 2 whole square. No, not necessary to move the further step because this here is constant. What's the next higher derivative value of the constant must be 0. Okay. In the next step, 1 by 2. I told number of times whenever having sine or cos product or independent sign cos, first verify what happened the corresponding limit. Now I'm going to verify the limit here before going to start the next step. I have to put x is equal to 0. What is sine 0 is 0. Okay. Put x is equal to minus 2 is there. Sine of n pi minus 2 divided by 2 cancel. Sine of minus n pi. What is sine of minus theta? Is minus sin theta. Minus sin n pi. What is sin n pi value is 0. Therefore, this what happen upper and lower limit, this value must be 0. Where to neglect this? This is 0. Okay. In the next step, yeah, observe carefully in the next step. Yeah, here also the product of x into sine is there. Sine of n pi by 2, apply the upper limit. Sine n pi is 0, sine 0 is 0. The entire this function must be 0. Now I have to verify what happened. Cos of n pi by 2 into 2 cancel cos n pi. You know what is cos n pi. What is cos n pi value is minus 1 to the power of n and cos 0 is 1. Cos 0 is 1. Now, only we go for this term minus into minus plus. This is comes in numerator. 2 square comes in numerator. What is 2 square is 4 by n square pi square of. Apply the upper limit. What's the upper limit? We get my 2 to cancel. What's the value? Cos n pi is minus 1 to the power of n minus cos 0 is 1. If we want to simplify further, what we get an, what we get actually 4 is cancelled with 2 by n square pi square of minus 1 to the power of n minus 1. What is denominator here? After once we get n square. N square is 0 in which case n is equal to 0, but our summation start from 1 to infinity. And also another one point already explained my previous video. Whenever in the flower bracket, one of the term is minus 1 to the power of n, another term is 1 or plus 1, even cases are 0 or odd cases are 0. Therefore, this can also be, this flower bracket can also be written as, observe this flower bracket, if you use some different color pen, minus 1 to the power of n minus 1. Yeah, what happened? If n is 1, minus 1 we get minus 2. If n is odd, what we get actually, if n is odd, If n is odd, minus 1, we get minus 2. If n is even, minus 1 whole square. What is minus 1 whole square? 1 minus 1, 0. Put n is equal to 1, 1, 3, 5, like that, we get minus 2. Put n is equal to even, 2, 4. Once we even, this become 1. 1 minus 1 is 0. Therefore, is minus 2 if n is odd. Okay. 0 if n is even. Therefore, based on that, we are going to write what is my an. I'm going to write my an is minus 4 by n square pi square, the common value for odd value. If n is odd. 0, because this flower bracket 0, entire thing is 0 if n is even. Okay. In the next step, I have to find out as usual for bn value. Yeah. My bn is nothing but bn is what actually 1 by 2. Apply the upper limit. What is my upper limit is, say, split the integral. What is entire integral is minus 2 to plus 2, minus 2 to 0. What's a function? Minus 2. If you want to see, observe here, what is my f of x? Just now I written already. What is my f of x? Is minus 2 to 0, x for 0 to 2. Okay. Now, minus 2 to 2. Minus 2 to 0 is minus 2 sine of n by x by 2 with respect to x. 0 to 2, what's the function? X into sine of n by x by 2 with respect to x. Okay, fine. In the next step, as usual, this is my u function, this is my v function. Okay, fine. Now, keep minus 2 as constant. What is integration of sine? Minus cos of n pi x by 2 divided by quotient of x, n pi by 2. What's the limit? Minus 2 to 0. Yeah. Now I'll come to this term. Now carefully I have to go for UV rule or Bernoulli's rule. X into, what is integration of sine? Minus cos of n by x by 2 divided by the quotient of x is n pi by 2. I'm doing a little bit fast because just few minutes before we already done for an. Minus, what is differentiation of x is 1. Again integrator, keep the minus n constant. What is integration of cos is minus sine of n pi by 2 by x divided by, again we get n pi by 2 whole square. Okay, let's close the bracket. What's the limit? 0 to 2. Before moving to the next step, we already verified this have sign, therefore what happen, upper and lower limit must be 0. Sin n pi and sin 0 is 0. After I have to put x is equal to 2 and x is equal to 0. Well, come to this, yeah, 1 by 2 of, this 2 comes in numerator, minus 4 by n pi. Minus into minus we get plus. Minus into minus, what we get actually? Plus. Minus into minus we get actually plus, therefore keep it outside. Apply the upper limit. What's upper limit is 0. What is cos 0? 1. Cos 0 is 1. Minus the lower limit. What is my lower limit? 2. Once you apply 2, what we get? Cos of n pi into minus 2 divided by into 2. What we get actually? Cos of minus n pi. What is cos of minus n? Cos of minus theta is cos theta, cos n. What is cos n pi is minus 1 to the power of n. And then, while come to this, plus into minus is minus 2 by n pi is constant. Apply the upper limit. What is my upper limit is 2. 2 into, again, cos n pi minus 1 to the power of n. X is 0 but cos 0 is 1. Okay. Simplify that. What we get actually 1 by 2 of Now observe carefully here. 4 by n pi of 1 minus of minus 1 to the power of n, and then this is minus plus into minus is minus 4 by n pi into minus 1 to the power of n. From these two terms, what's a common factor? Observe carefully. 4 by n pi is a common factor. What we get? 1 minus 2 times of minus 1 to the power of n. If we want to simplify further, what we get my Bn is 4. 2 ones are 2 twos are 2 by n pi of 1 minus of 2 into minus 1 to the power of n. Now I'm confidently write this is true for n is equal to 1, 2, 3, etc. Why? Because observe the denominator. What's the expression have? N. N is 0 for n is equal to 0, but our summation start from 1 to infinity. Therefore, this is now this is only I told even or odd case I have to write inside the bracket have one term is 1, another term is minus 1 to the power of n. Instead of minus 1 to the power of n, what you have? 2 extra. Either even or odd case, none of the case is not equal to 0. Here, if you want to put n is equal to 1, what happen? 1 plus 2 minus 3, and then none of the values not equal to 0. In even case, what happen? 1 minus 2. What is 1 minus 2? Is minus 1. Even case also non-zero, odd case also not equal to 0. Only the case one of the term is 1, another term is minus 1 to the power of n. But here extra having 2, in even case also not equal to 0, in the odd case also not equal to 0. Therefore, now I have to go into construct the Fourier series. Now, what is my Fourier series based on the a0, an and bn? If of x equals a0 by 2, a0 is minus 1, a0 by 2 is what? Minus half. While come to the an, which case 0, even case 0, only I have to take odd case. In the odd case, what's the value? Minus 4 by n square pi square. What's a constant? Minus 4 by pi square is a constant. Minus 4 by pi square is a constant, but only we are going to take odd value for 1, 3. I told in my previous videos, whenever I have to take only odd even value, I have to mention first two values. Otherwise, 1 to infinity means they are mixed with both. Okay, pi, yeah. Oh, what's actually 1 by n square cos of n pi x by 2. While come to this 2 by pi summation in ranging from 1 to infinity 1 by n 1 minus 2 into minus 1 to the power of n sine of n pi x by 2. This is nothing but actually is the required Fourier series for the given function over what's the interval minus 2 comma plus 2. Yeah, for time being I'm going to treat this as must be star because I want to deduce what they expecting in the deduced part. This is construction of Fourier series fine. I want to this see another one point I have to remember. The given interval is in the form of minus LTL, but function is neither even or odd. There is no alternative. I have to find out A0, N and B, and I have to write the formula based on the second case formula. What I did just now, similar way. Okay, this is one of our important problem. What they expecting the deduced part. Prove that or deduce that what actually pi square by 8 is nothing but summation in ranging from 1 to infinity 1 by 2n minus 1 whole square. Observe carefully, this is my two summations you have, but they have only one summation. But they have whole square. Yeah, you know that summation n ranging from odd values 1, 3, 1 by n square can up to infinity can also be written as summation 1 by Instead of n, what we are going to replace? N 2n minus 1 for n ranging from 1 to infinity. We already discussed this. Put n is equal to 1. What happened? 2 minus 1 is 1 square first term. Put n is equal to 2. 4 minus 1, 3 square. Instead of taking odd values 1 to 3, can also be written as 2n minus 1 whole square for n ranging from 1 to infinity. Okay, that's okay. But we don't have any cos. But here we are having cos. I try to convert here cos of n pi x by 2 value must be equal to 1. I want to retain this summation of this value. Are you clear why I retain? Because our required result is 1 to infinity 1 by 2n minus 1 whole square. Odd cases can also be written as 1 by 2n minus 1 whole square. Only thing is I have to convert this cos of n pi by 2x must be equal to 1. For what value of x we get cos of n pi by 2 value must be 1. In the range, what's the range here? Minus 2 to plus 2. You can't take any value. I have to take within the range. Now, and I don't want simultaneously, I want to convert this summation must be 0. Therefore, what's the value of x? Suppose choose x is 0. You know sin 0 is 0, but cos 0 is 1. 0 is in the range minus 2 to plus 2. Therefore, put x is equal to 0 in star, we get f of 0 is nothing but minus of minus 4 by pi square summation n is odd value only 1 to 3 by n square. But what's the function they given? What's the function? F of x is minus 2 to 0 x 0 to 2. Observe, I want to find out f of 0. Either 0 is not included in this range or is not included in the second range. It's not included in the first interval or not included in the second interval. Therefore, 0 is a point of discontinuity. If you want to plot a graph for this function, we get a break at which point 0 because 0 is not included. Suppose they are given as less than or equal to 0, then I have to say that is what is my f of function up to including 0. Or either greater than or equal to 0 means 0 is included in the second interval. In both the case, they return strictly less than 0, strictly greater than 0. 0 is a point of discontinuity. How to find out the value of the function at the point of discontinuity? I take the average between left hand side and right hand side limit. Limit as x tends to 0 of f of x plus take the average of left hand and right hand side limit of the function at the point of discontinuity. Average means divided by 2. Yeah, x tends to 0 minus left of the 0 minus 2 to 0. What's the function? Minus 2. Function is minus 2 is a constant. What is f of 0 for minus 2 is minus 2 only. Plus. Now, x tends to 0 plus means right of the 0. Right of the 0, what is my x greater than 0? What is my function is x. F of x is equal to x. Put x is equal to 0 because I want to find out f of 0. What is the value? 0 divided by 2. Then you simplify that. What we get actually, f of 0 value is minus 1. Here 0 is a point of discontinuity. Okay. Now, once we get the value of x, and then I have to proceed the next step. Okay. The final step is minus 1. Now I have to shift it minus of in the left hand side. What you get? Plus of must be equal to minus 4 by pi square of. Now this summation can also be written as just few minutes before I explain how I to express in terms of what actually in terms of odd value 2n minus 1 whole square is nothing but 1 to infinity. Instead of n, what we are going to take 2n minus 1. Yeah, even multiple, odd or even, subtract 1, definitely we get odd only. Okay, even multiple of n may be even, n may be odd, we get a even value. We are subtracting 1, definitely we get an odd value. Okay, you simplify that. What is minus of half is minus half. Okay, both the sides having negative sign, you neglect it. What we get, pi square by 8. Here also have negative sign, here also negative sign. Pi square by 8 is nothing but summation in ranging from 1 to infinity 1 by 2n minus 1 whole square. This is a required result what they expecting in the problem. Now observe carefully. Before I'm going to wind up this class, again I have to recall this how we have to do. Suppose the function is a splitting function. Observe carefully. Now what's a given function is? The given function is actually f of x is what they given. F of x is a Fourier series. What they expecting here? They expecting find the Fourier series for the function minus 2 in between minus 2 to 0, x for 0 to 2. Reduce part later. Now overall interval is minus 2 to 2. Therefore, within fraction second, I verified its function is neither even nor odd. It's not satisfied one of the interval, not necessary to verify the second interval. And then I had to construct Fourier series. Before construct the Fourier series, first I had to know what's the value of L, what is my n by x by L. Keep in mind while writing a naught, a and b, and I had to write 1 by L, not for 2 by L. 2 by L only we get in even case, odd case. Just we are taking case 2 formula we are constructing. After that we are find out an and a naught, an and bn very carefully. We have to split the integral minus 2 to 0, 0 to 2. Now after that I told whenever having sin or cos, first you verify that corresponding limit what happened. Based on that I have to find out. Once we get AL is true for n is equal to 1 to 3, but you have in the flower bracket one of the term is minus 1 to the power of n. Another term is minus 1. Commonly even cases are 0, odd cases are minus 2. Therefore, I have taken odd case separate, even cases 0. Similarly, I have to find out Bn, but don't apply even or odd case in Bn value because it's minus 1 to the power of n is multiplied by 2. Even though I have to take odd or even in both the cases, Bn value is not equal to 0. Therefore, after you construct the Fourier series, you compare the deduced part. In the deduced part, you have 1 by 2n minus 1 whole square for n ranging for 1 to infinity. Only the odd cases can also be written as 2n minus 1. Yeah, we get as what they expecting 1 by 2n minus 1 whole square from an. But I want to eliminate b in this summation. I to convert this cos must be 1, therefore I have to take put x is equal to 0. Before going to take 0, first verify whether 0 included or not in the interval. Definitely included. Then minus 2 to 2, therefore confidently I have to write put x is 0. But the thing is x is 0, the function is not defined at x is 0 either in the first interval. 0 is not included in the first interval or maybe in the second interval. Therefore, such type of point we are considered as a point of discontinuity. How to find out the value of the function at the point of discontinuity? Take the average of left hand and right hand side limit for the corresponding limit. Now we have to find out the left of the 0 means x less than 0, minus 2 is a f of 0 is minus 2 only. Right of the 0 means x greater than 0. A function is x, put x is 0 because I want to find out limit at the point x is equal to 0. Automatically we get f of 0 is minus 1. Substitute and simplify. Automatically or immediately we get the required result is n ranging from 1 to infinity 1 by 2n minus 1 whole square must be equal to pi square by 8. This is a way to, this problem is one of the important problem. This problem having a splitting function is neither even or odd function, and also deduce part what we are choosing a value for if of x is equal to 0 value, 0 is a point of discontinuity. In this problem, I explained how to evaluate function is neither even or odd in the interval minus n to l, how to find out the value of the function at the point of discontinuity. Thank you very much for listening my talk, and I will come and meet in the next class some more problems. Bye, see you, take care.